Welcome back. In this problem, what I want to talk about is diode states, whether the diodes are on or off, or what conditions will allow them to be on or off. To look at that particular aspect of the diode problems, let's look at the following circuit and ask the question, what range of the input voltage Vn will allow diode 1, D sub 1, to be on? And we're not concerned about D2 other than it needs to be functioning. We're assuming ideal diodes. It needs to either be in an off state or an on state, and what range on the input voltage allows diode 1 to conduct or to be on. To get started, so now we're really looking at two possible cases. We have D1 on and D2 off. We're always looking to find when is D1 on, and we have D1 on and D2 on. Those are the two circuit configurations that we're interested in to see if we can find, is there a consistent range on Vn when both of those might be true, or when Vn will allow D1 to be on and D2 to be off or on. Let's make the first combination of those diodes. Let's examine this circuit when diode 1 is on or conducting and diode 2 is off or opened up. That's our first analysis. So we're really going to look at two different circuit configurations. First, let's look at diode 1 being on and diode 2 being off. In this particular configuration, then, with those assumptions, we haven't changed anything with respect to the resistor, but now we are assuming that diode D2 is off, so it will be opened up. Diode 1 we were assuming was conducting. It's going to now act like a wire with an ideal diode assumption. This was 1K, here was 1K, and here is our input source Vn, which we are allowing that to be in some range, positive or negative, or bigger than 10, less than 10, something. And there's our 5-volt source. The anode side of diode 2 was in the top end, or on the top terminal. And if diode 2 is off, then V sub D sub 2 needs to be negative when we do our analysis. Let's now assume that we have this configuration, and we're wanting to know, in this configuration, is I sub D positive? Is current going in the direction that it is allowed through our one-way valve of diode 1? If diode 1 is conducting, then that means current is flowing, positive current is flowing from the anode end to the cathode side of the diode. So I sub D needs to be positive, and V sub D2 needs to be negative. Under what conditions on Vn will that be true? Let's look at a couple of different analysis points. We can now find I sub D by simply writing a KVL equation around that outer loop. Let's do that. We now have a KVL around the outer loop. Doing that, we have minus Vn plus 1K, and the current through that horizontal resistor is I sub D. There's no current flowing through the second diode, that's opened up, plus the vertical resistor times the current I sub D. We can now solve for I sub D from this outer loop equation, and we see that I sub D is Vn over 2K. And we want that to be positive, for current to flow, and that's going to happen as long as Vn is greater than 0. Now, is it true that V sub D sub 2, or the second diode, is actually opened up? So we need to check that to see if this configuration is consistent with what's happening. So let's now find this V sub D sub 2, and if diode 2 is off, then what we're hoping to see is that V sub D sub 2 is less than 0. Let's now do a KVL around the right loop, where the right loop now, let me do that in a slightly different color, this is the right loop that I'm referring to in green. So we're going up through Vn, we're entering the negative terminal of the source, so we'll have minus Vn plus 1K, the current is still I sub D, then we'll drop down through V sub D sub 2, which is an air gap. We can find that voltage drop across that air gap, and then we'll go into the positive terminal of that battery, that 5-volt battery, plus 5 volt, and that will be our KVL equation in the right loop. Why did I say right loop? That should be the left loop. So let me correct that. That was, can't seem to tell direction. So we now have KVL on the left loop. KVL on the left loop is, oh, that's why I said right loop, is because I wanted the right loop. Let me not do that KVL. Let me erase the green and say that what I really want was what I had written down. Let me do KVL there on the right loop. So there's the right loop. I don't want to inject Vn into this any more times than I have to. So let me go back and correct my correction and say let's keep with the right loop and do the KVL there. If we do the KVL on the right loop, then we go up through the battery of minus 5, then we have minus V sub D sub 2 plus the 1K times I sub D on the far right vertical resistor path, and that's equal to 0. We can now solve that for V sub D sub 2. V sub D sub 2 is now this 1K times I sub D minus 5, but I sub D we already found an expression for in this circuit configuration. I sub D was our Vn over 2K, and so now we have V sub D sub 2 as 1/2 Vn minus 5. In order for V sub 2 to be off, or I'm sorry, for diode 2 to not be conducting, or for diode 2 D2 to be off, then we need V sub D sub 2 to be negative. If that's the case, which is 1/2 Vn minus 5 less than 0, we now have 1/2 Vn less than 5, or for this configuration to be true, we need Vn to be less than 2 times 5, or 10 volts. And we've already said that Vn needed to be positive for I sub D to be positive, and now we found a range for D1 on and D2 off requires Vn to be positive and less than 10 volts. Let's now see what happens with respect to the possibility of both of those diodes being on if we can go further or higher than 10 volts. So let's look and see. Right now we've found that Vn needs to be 0 and 10, or between 0 and 10, positive. Let's look at the question, can diode 1 and diode 2 both be on? So we know diode 1 is on as long as Vn is between 0 and 10, and diode 2 will be off as long as the voltage Vn is less than 10. Let's look at what the circuit is when both diodes are conducting and see if this can be true. Here's our 5-volt battery. Here is Vn. Here's our 1K. Here's another 1K. And now we have actually more currents to be worried about. Let's call this I1. Let's call this I2. And let's call this I source. Now I think it's clear that I1 is just going to be 5 volts divided by 1K, or that's going to be 5 milliamps if this circuit is valid. It's always going to be 5 milliamps because we just have 5 volts across it as long as diode 2 is conducting. So now let's do a KVL around the left to see if we can actually see that I sub 2 is positive. If I sub 2 is positive, then diode 2 is conducting. So around the left branch or mesh, we have minus Vn plus 1K times I sub s plus 5 is equal to 0. Well, Vn we're going to say we have control over. I sub s is the variable that we're trying to solve for. We now have 1K times I sub s is equal to Vn minus 5, or I sub s is now Vn minus 5 over 1,000, or we're going to have Vn over 1,000 minus 5 milliamps. But remember what condition we are in. We know that we need to have Vn bigger than 10, otherwise diode 2 is off. So we know that, recall from what we've already done, Vn must be larger than 10 volts for this pattern to be true. And if Vn is bigger than 10 volts, then we can see, I think, that says that I sub s, Vn bigger than 10, this now Vn minus 5 over 1K is now we're saying bigger than 10 minus 5 over 1K, or this is 5 over 1K, or 5 milliamps. So we're saying that I sub s needs to be bigger than 5 milliamps in order for this to be true. And if we look at this circuit and write a KCL equation here, KCL says I sub s is in, I sub 1 and I sub 2 is out. So we have I sub s is equal to I1 plus I2. I2 is then I sub s minus I1, and we said that I sub s, or I1, was 5 milliamps. What we just said that is if Vn is bigger than 10, then I sub s is bigger than 5 milliamps, and so this I sub 2 will be positive if Vn is bigger than 10. That says then that Vn bigger than 10 will provide us with D1 on, D2 on. And Vn being bigger than 10 will then be allowing I2 to have current flowing in the positive direction, or essentially we're charging that 5-volt battery. If Vn is negative, neither diode is going to be on, and so now we can conclude that for D1 on, all that really requires is that Vn is positive. Now whether D2 is on or off depends on what particular value Vn is. If D2 is off, then Vn is only going to get up to 10 volts. If it's on, then we know that Vn can go, or needs to go, beyond 10 volts. Now, is it possible, so you might be saying, so that's really our answer to that particular problem. Another question could be, can D2 be on and D1 off? This is not what was asked, but we could ask this now. So can diode 2 be on and D1 off? Let's now sketch the circuit according to that assumption. Here's our plus 5 volts, here's our 1K, here's our 1K, here's our Vn, and here is our D1 voltage, or diode 1 voltage. If diode 1 is to be off, that requires VD1 to be less than 0. And so we can say, is VD1 less than 0? And hopefully by looking at this KVL equation, we see that minus 5 plus VD1 plus 1K, and there's no current flowing through this branch since there's an open there across the diode. We see then that VD1 is equal to 5 volts, which is not less than 0, which says then that D1 is not off if diode 2 is conducting. So we know that that condition cannot be a valid condition. But we'd already solved the earlier problem, that the main problem that we'd asked, and that was, when will diode 1 be on? Diode 1 will be on as long as Vn is positive. And that's the answer to our original question.